SwayamPrabha. Digital India. Educated India.
Then let us say case 2. Case 2. Here MB is known to be a steep downward sloping curve, but MC is unknown. So, let us say that this is again pollution control, or permit, both you can measure, and this is dollar MB and MC. This is, let us say, your MB, this is expected this thing. So, this is XM, amount of permit given, okay, decided. Now, if your XM X, this is, let us say, marginal cost higher. So, this is XH star, and let us say, so in this case what is happening? In this case again XH star is lower than this. So, that means firms are forced to go up to XM level of pollution control, right. So, that means there is divergence between social optima and private optima, but if you compare this situation with the earlier one, the amount of divergence is coming down. So, the amount of divergence is coming down in this case, right. Similarly, if it is MC low, so this is the amount of XL star. Again there is a divergence between private optima and social optima, but the amount of divergence is going down. So, that means tradable permit system works better when the marginal benefit is steep straight line. If you make it even more steeper, then the divergence, the difference between XM and XH and XM and XL will go down. So, that means in this case permit system works better. Okay, permit system works better. If you make it more flat, then in case 3 what will happen? Let us say that this is case 3, MB is actually flatter than case 2. What will happen? So, this is your, instead of steep straight line, let us say that MB is like this. So, this is your EMC. So, this is your MCH So, that means this is xm, this is xh star, let us say this is xl star, right. So, again what is happening here? What is happening here? The divergence between the difference between xm and xh, in this case xm minus xh star in case 3 is higher than, I will say that xm minus xh star in case 2. Similarly, the difference between xm and xl star is higher in 3 compared to xm minus xh in 2, case 2. Okay, case 2. So, that means the permit system works poorly when your marginal benefit curve becomes flatter, and if you rotate this MB again clockwise, then you will get a situation where MB will again become a flat straight line, and then permit system will be fully ineffective. So, that means the effectiveness of permit system and emission charge is just the opposite. Okay? When the policymaker is uncertain about the marginal cost of control, but certain about the marginal benefit, in that case these two instruments works in a different direction. Okay? They works differently. While emission charge is fully effective in the case 1, it is completely ineffective in case 2, in case 1 in case of permit. Okay? And then as the MB curve becomes flatter or steeper, the effectiveness of permit system and emission system is just quite different. So, you need to compare these cases to understand the mechanism. Okay? Now, in short, in nutshell, why the permit system is not working fully in this particular system? Because permit system is not flexible like emission charge. Okay? Permits once allotted can't be taken back. That is where the problem arises. Okay? Permits once allotted can't be taken back, right. Now, there is one more instrument based on this experience of permit system and emission system. Some economists, they suggested a hybrid system. What is that hybrid system? So, that means you have a system wherein multiple instruments are working simultaneously. So, you have emission tax, you have permit, and you have some amount of subsidy also, and if that is the case, that is called hybrid system. Hybrid system. So, what happens in that case? Let us try to understand a hybrid system, effectiveness of a hybrid system. So, here it is pollution control, and here it is dollar. Okay. Let us say that this is basically this is basically your EMC, expected marginal cost, expected marginal cost, and this is your, sorry, this is your XM. XM is the permit. Okay. XM is the permit, and XM is the permit. If your actual cost of abatement is higher than this expected one, then what happens? Let us say that this is MCH. This is MCH, and let us say that this is your MB. MB is, this is your MB. So, intersection between MB and EMC decided about the optimal level of permit, right? Optimal level of permit. So, if it is higher than this, so obviously there would be a divergence. There would be a divergence because XM is higher than this. Now, how will you solve this divergence? The divergence, to solve this divergence, what happens? You impose a tax. Let us say that this is the tax rate. Okay? Or let us say, instead of this, let us say that the tax rate is actually this. This is the tax rate. Okay? So, this is, let us say, XH in mixed system. So, that means when your marginal cost is higher than the expected, you have one tax rate also. Okay? You have one tax rate. Is that fine? So, what is happening here? Even though you have a divergence, the divergence is actually going down. Why? Because the difference between XH star minus XM is actually higher than XH star minus XH in MS. MS means mixed system, right? So, by imposing a tax also, if I allow a tax also, then what is happening? That system works better than a system where only the permit system is working, right? Similarly, let us now assume that your MC is actually lower than what you expected. So, this is again the optimality, which is, let us say, XL star. Okay. All right. So, there is a difference between XL and XM. To solve this divergence, what the policymakers are doing, they are actually giving a subsidy here. Let us say that this is subsidy S. And when the subsidy is given, then what will happen? They will equate the subsidy amount, subsidy is given, let us say, this is subsidy is given here, this is subsidy. So, this is the amount, let us say, XL in MS. So, here also XL star minus XM is greater than XL star minus XL what I will say that instead of this, I will say that this is, sorry, instead of writing in this way, I will write in that way. Let us say that x m, the first condition, x m minus x h star is actually greater than x m minus x h m s. Okay. In this case also, x m, the divergence minus x L star is again higher than x m minus x L star, sorry, in this is m s actually. M s. Right. So, that means in this hybrid system, what are the instruments working? Tax, subsidy and permit. Now, what we are trying to do here? So, this is a hybrid system of tax, then subsidy and permit. When actual abatement cost is higher than expected, we are imposing tax also to reduce the divergence. When the actual tax rate is lower than expected, then we are giving subsidy. Why this is so? Because if we allow permit system to work alone, then there would be too less of pollution control. We have already seen earlier that when this is low, permit system is not flexible, we will have too less of pollution control. Now, how to motivate the firm to go for more pollution control? In this case, you give subsidy. Additional pollution control means you will get some amount of subsidy. When the actual cost is higher than what we have expected, we have seen earlier, if the permit system works alone, then we will have too much of pollution control. Okay? Too much of pollution control we are expecting. That means in that case you impose some amount of tax. So, this tax will motivate the firm to go up to this much. So, the divergence will come down, right? The divergence will come down. So, that means with this hybrid system, actually then what is happening here, if you look at our marginal benefit curve is actually not this MB curve, rather the effective marginal benefit curve is a step function like this. This is like this and then this. Please try to understand. So, instead of having a downward sloping MB, rather our effective MB is actually a step function. So, hybrid system tries to approximate the MB curve as a step function. That is why the divergence is actually going down. If you in reality if we make more steps in this step function, the effectiveness of hybrid system improves, but more the number of steps you make, if the number of steps is more, then it would be very challenging for the policymaker also to assign that many tax, subsidy and XM, because too many steps means too many tax and subsidies. Here I have only one, but then in ideal case what will happen, your benefit curve will be like this. Like this. So, too many tax system, right? And in extreme case again it will become like a downward sloping. That means you have too many teeny steps in this MB function. So that is how a hybrid system works better than the permit system alone, because what is happening, we are trying to utilize the benefit of permit system and the benefit of tax system in this hybrid one. When the MC is actually higher than the expected one, then what is happening, there is too much of pollution control we are expecting in a permit system alone, then tax system dampen that type of, it gives a dampening effect and increase the optimal level of pollution control, and that is why the divergence goes down. Similarly, when it is low, then too less of pollution control we are asking for, and the moment I impose this subsidy, then that gives some kind of additional incentive to the firms for going for extra amount of pollution control, and that is why you can see from here that xm minus xh star, the divergence is higher when this is permit system alone. This is permit system alone. This is the divergence, ineffectiveness, and this is actually hybrid system. Hybrid system. This is again permit, this is hybrid system. So in both the cases, whether your actual marginal cost is higher or lower, we can see that the divergence, amount of divergence in case of the hybrid system is lower than permit system working alone. That is why we say that a hybrid system is actually better than the permit system or tax system working alone, because here we are trying to take the advantages of both the system and combining into a hybrid one. So with this we are closing our discussion today, and we will meet again in our next class to discuss the remaining portion of this incentive designing. Thank you.